Wait for a while, class. Delete ko lang muna yung Okay, let me share my screen. Is my screen visible?
Yes po.
Okay. What happened? So the problem is there is a plastic cube with a negligible weight containing an unknown material is hanging from a string while submerged in water. One side of the plastic cube has a length of 5 cm and the string experiences a tension of 15 newtons. What is the specific gravity of the unknown material? And there is a note that there is no net force acting on the cube, and we're given of the formula of the buoyant force. So the formula for buoyant force is density of the fluid times the volume times the gravity. So let's start with the given. Oh, oops, wait lang. Start tayo sa given. So we have, we're given of the dimension of the cube. So we have 5 cm. And then we're also given of the tension, which is 15 Newton. And then, ano pa? Ano pang given? Wala na, no? So in this kind of question class, so sinabi no, there is no net force acting on the cube. So if there is no net force acting on the cube, meaning the cube is in what? Is it in dynamics or yes, you can speak.
At rest
Hello.
po, ma'am.
Yeah. Yes. So meaning the cube is at rest. So before we start with the solution, let us first draw the free body diagram. So when you encounter this kind of problem, it is really helpful if you do the FBD. So we are going to draw the FBD of the cube. So what are the forces acting on the cube? First, ano yung sinabi sa atin, no? We are given of the tension. And what is the direction of the force for a tension? Is it upward or downward? Is it
Upward.
this? Yes, correct. So always remember, class, that the tension force is always going away from the body when you draw your FBT. So laging, wait lang. So you have here your tension force. What are the other forces acting on the body? Yes?
Weight po.
Yes, Dave. Yes, we also have the weight of the cube. And the weight, what's the direction of the force or the weight? It's always
Downward po.
yes, correct. So we have here the weight. And the last force acting on the cube, what's the last force?
Buoyant force po.
Correct. And the direction of the buoyant force is
Upward po.
correct. So we have here FB. So class, remember, no, in your fluid mechanics or fluid machinery, you'll encounter this buoyant force. So buoyant force is the force which uh, is always against the weight of a substance submerged in water. No. So since the cube is at rest, we'll have the summation of forces equal to what's what's the equivalent of the summation of the forces. Correct. So whenever an object is at rest, then the summation of forces acting on the object is always equal to zero. And then we'll now write the forces. So all upward forces is positive and all downward forces are negative. So we have here tension plus the buoyant force, and we have the weight. So rewriting this, we'll have FB, and then weight is equivalent to mass times the gravity. It's equal to tension plus force. And then we'll divide both terms by gravity, no? So we'll have our first equation. So dividing both terms, we'll have mass is equal to T over G plus the buoyant force over the gravity. So this is our equation 1. Okay, now, since we are given dun sa of the dimension of the cube, what's the formula for the volume of the cube? What's the formula? Anyone?
Side cube po.
Correct. So the volume for a cube is S cube, and we are given of the dimension 5 centimeter cube. So our volume is 125 cubic centimeter. So now, uh, let's use the formula for the buoyant force, no? So solving for the buoyant force, since we already have the volume, we have the formula density of the fluid times, so this is H2O, volume of the cube times the gravity. So this is equivalent to, what's the density of water? Density of water,
1,000 po.
1,000 what? What's the unit?
Kilogram meter cube po.
Kilogram per meter cube. So since our given here is in centimeters, let me convert this to gram per cc. Dito na lang sa ating solution. So since we have 1,000 kilogram per meter cube, how many centimeters are there in a meter? We have, correct, 100 centimeter. So don't forget the cube. And then for the kilogram, we have 1,000 grams per 1 kilogram. So this is for the density pa lang. And then we're given of the volume of the cube. Na-solve na natin. We have here 125 cubic centimeters. And then what's the value of gravity in metric unit? We have 9.81 meter per second squared. So, cancel tayo. Cancel na si kilograms. Makakancel na rin yung centimeter cube. Ano pa? Ito, magiging cube na lang. Sorry. So, the answer here is anyone? May nakapagsagot sa class? So, cancel na din natin to. So, we'll have here 120, sorry. 125 G times 9.81 meter per second squared. Sorry. Convert ko na lang ulit si 9.81 to the gravity since isa-substitute din natin siya on our first equation. So let me just convert this to kilograms. So we have times 1 kilogram over 1,000 grams times the value of gravity. So we'll have 0.125 kilograms times gravity. So this is the equation number 2. So substituting this, the first equation, we'll solve for the mass of the mixture or the unknown material. So we'll have from equation 1, di ba ang equation 1 natin is mass of the mixture is equal to tension over gravity plus buoyant force over gravity. So let's just substitute yung mga meron na tayo. So we have here 15 Newton meter per second squared plus our buoyant force. So we have 0.125 kilograms times gravity all over gravity. Ito. So, pa-cancel ko na siya. Kaya hindi ko na siya sinimplify kanina. And then, anong equivalent ng 1 Newton conversion?
Kilogram meter per second squared po.
Correct. So we'll have, sorry, this 1 Newton is equal to 1 kilogram meter per second squared. So let's substitute 15 Newton times 1 kilogram meter per second squared ay 1 Newton convert tayo mabura. All over 9.81 meter per second squared. So let's cancel meter per second squared, meter, Newton, Newton, second squared. Pero hindi pa dyan tapos, meron pa tayo ditong 0.125 kilograms. So our mass here is
65405,199 po.
0.5199.
Opo.
So this is the mass of the mixture. And then since we are asked to find the specific gravity, since we already have the mass of the mixture and the volume of the mixture, we're now able to find or to solve the value of the density. So solving for the density of the unknown material is equal to the mass of the unknown material over the volume of the unknown material. So we have here 1.65405,199 kilograms all over, what's our volume again? 125 cm cube. So solving for the density, we'll have 13 point, sorry, kinonvert ko na pala to. So we have here 0.013
2,
23242 kilogram per cubic centimeters. So for the specific gravity, we have the the density of the unknown material over the reference medium, which is water. So we'll have 13.23242. Kinonvert ko pala to into grams. This is also equivalent to 13.23242 grams per cubic centimeters. Para anyone who knows the value of the density of water in grams per cc?
1 po.
Correct. So we have 1, no? So tandaan nyo to, no? So density of water is 1 gram per cc. So our specific gravity is 13.232. Yan na lang. 3 decimal places. What's the unit for specific gravity? Correct. Very good. So any questions dito sa problem number 4? Everything clear?
Clear po.
How about the others?
Clear po.
Okay. Mabilis ba or carry lang? Or masyadong madali yung problem? Is the problem too easy to solve? Okay. So now, since we're done already, we'll proceed with our next topic, which is pressure and temperature. So let me just share the material here. But before we proceed with the definitions of terms, I'll call names again and check if you did some advanced reading. This is only a 7-item questions. Let me call on Mr. Reggie. Mr. So what's gonna happen is that I'll call your name and then you'll just answer my question. So you have 3 seconds to answer. If you miss the opportunity, then it's a miss already. It's 1 or 0, no? So Mr. Cardenas Reggie. Hello? Mr. Cardenas? Mr. Cardenas? Wala siya. Reggie? Mr. Cardenas? Last chance. I'll mark this as absent if no answer in 5 seconds. 5, 4, 3, 2, 1. Okay, absent. Next, Aldrin Malabanan. Aldrin,
Yes po, ma'am.
hello. So the question is, what's the equivalent of 1 atmospheric pressure in kPa, kilopascal? Again, 1 atm is equivalent to blank kPa. Answer? 3.
101.325 kPa.
Correct. So 1 atm is equivalent to 101.325 kilopascals. Next, Alan May Valdez.
Yes po, ma'am.
So 1 atm is equivalent to blank psi. 1
14,
atm. Again, sorry, what's the answer?
14.7 po.
Correct, very good. Next, may I call on Mr. Adonai? Mr. Adonai?
Yes po, ma'am.
Okay. 1 atm is equivalent to blank torr. Torr. 1
Um,
atm is equivalent to blank torr. Answer?
ma'am, what 1 ATM is equal to 760 bar.
Correct. Very good. Next, Bea Patrice.
Yes po, ma'am.
Question is, 1 atm is equivalent to blank mmHg or millimeters of mercury. 1 atm is equivalent to blank mmHg. Answer?
760 po.
Correct. Next, Mr. Charles Benedict Valin.
Yes po, ma'am.
Question is, 1 atm is equivalent to blank inch Hg. 1 atm is equivalent to blank inch of mercury. Answer,
Ma-
please.
Ma'am, 1 atm is equals to 29.92 inches mercury po.
Correct. Next, may I call on Mr. Alvin Anthony?
Hello po, good morning po.
Morning. 1 atm is equivalent to blank bar. 1 atm is equivalent to blank bar. Answer please. 3, 2, 1, 0. So the answer class, 1 atm is equivalent to anyone.
1.013 bars.
Correct. So 1 atm is equivalent to 1.01325 bars. Next, last for the pressure, may I call on Roma Santa, John Gabriel.
Yes po.
So 1 atm is equivalent to blank meter H2O. 1 atm is equivalent to blank meter H2O. Answer. 3, 2, 1, and anyone from the class? Yes, Miss Sada.
10.34 meter H2O po.
Yes, correct, no? So 1 atm is equivalent to 10 point, in my notes is 10.33. So we'll use 10.33 meter of H2O. Okay, next. I have here another two. For the temperature, Adham. Adham, are you there?
Hello, ma'am.
Hello. So what's the equivalent of 0 degrees Celsius in Kelvin? What's the equivalent of 0 degrees Celsius in Kelvin?
237.15 Kelvin.
Again, sorry.
The
200.
0 degrees Celsius is equal to 237.15 Kelvin.
Is it 237?
273.
Correct.
Sorry, ma'am.
It's okay. So the answer is 273.15 Kelvin. Next. Ninya. Bizcocho.
Yes po.
0 degree Fahrenheit is equivalent to blank Rankine.
460 po.
Correct. So in our problem solving class, we'll use 273.15 in Kelvin, no? And 460 when we're converting to Rankine. Okay, let's now proceed with the discussion. Hello, is my screen visible?
Opo.
Yes po.
Okay. So today we'll discuss wait, pressure and temperature. Wait lang. Okay, start with the definition of pressure, no? Pressure is defined as a force per unit area. Units of pressure are often denoted by unit PSI. What's the meaning of PSI? Correct. How about KSI? Have you encountered the unit KSI? Correct. And we also have kilonewton per meter squared or kilopascal. 1 Pascal is equivalent to how many Newton per meter squared? Again, question is 1 Pascal is equivalent to blank Newton per meter squared. What's the answer? So that's 1:1, no? Okay, so 1 Pascal is equivalent to 1 Newton per meter squared. So important terminologies relating to pressure are as follows. We have gauge pressure. Gauge pressure is the pressure actually measured by using a pressure gauge or some sort of formula in determining it. Measurements always neglect the effect of the atmospheric pressure. It can be well defined using the formula below. So P gauge is equivalent to rho GH, where rho is the density of the medium, G is the acceleration due to gravity, and then last is H, which is the height of the column under analysis. So class, if you remember, no, or I don't know if you already read about the uh, Tor Tor unit. So Tor unit was what you call that? Formulated, or Tor unit is uh like there's an experiment before which is conducted by a scientist which name is Torricelli. So he conducted an experiment of finding the equivalent pressure or the equivalent of 1 atm using different fluid. So when Torricelli used mercury, he found out that 1 atm is equivalent to 760 millimeters of Hg. So if you'll notice, 1 torr is equal to 1 millimeter of Hg because it was named after him. Okay. Next is we have atmospheric pressure. So atmospheric pressure, it is the pressure measured using a barometer. It is the resulting measurement. So resulting measurement always indicates an existing barometric pressure in a certain area. So PATM. Next naman, we have absolute pressure. Say is done. What's absolute pressure?
Ang babasahin.
Basahin mo lang.
Absolute pressure is defined as the sum of gauge and barometric pressure. It indicates a total pressure acting on a body. Conversely, all value of pressure reading in reference with the absolute zero pressure is called absolute pressure. It is well defined using the formula below. Absolute pressure is equal to ab- VATM plus minus PG.
Correct. Next, we have vacuum pressure. Clear naman ang everyone with the absolute pressure, no? Any questions so far? Wala pa naman. This is basic terminologies pa lang. Next, vacuum pressure. Kindly read Miss Lizelle De Castro.
Vacuum pressure is the pressure lower than atmospheric pressure or a pressure reading below zero gauge pressure. In such case, vacuum pressure will take a negative sign convention when involving such pressure in every computation.
Okay, next. Absolute zero pressure. Andito na ba si Reggie Cardenas? Wala na talaga siya, no? Okay, how about Hernandez Joan? Please read.
Absolute zero pressure is the pressure lower than atmospheric pressure, and it's often termed as a perfect vacuum.
Okay, so let's remember, no, we always use positive, or the pressure is positive for gauge pressure, and use negative for negative gauge pressure or the vacuum pressure. So we have here an illustration of all those terminologies, no. So say we have here the atmospheric pressure and pressure above ATM. So let's use this as the baseline, atmospheric pressure. So below atmospheric pressure, we have the vacuum pressure. So here, this difference between the atmospheric and the absolute pressure. Di na siya And then have here absolute pressure that is less than the atmospheric pressure. This is our zero pressure. So the sum of everything is the absolute one. Okay, let's have a sample problem to better understand the pressure concepts. Let me open my note. So you can write this as well in your notebook. Now, this is sample problem number 5. So sample problem number 5. I'll read the problem. So calculate the height of the mountain above sea level if the barometric pressure at the peak is 92,091.28 Pascal. Assuming the air density equal to 1.3 kilogram per cubic meters. So again, our problem is calculate the height of a mountain above sea level if the barometric pressure at the peak is 92,091.28 pascals, assuming the air density equal to 1.3 kilogram per meter cube. So I'll give you 2 minutes. Try to answer this. And then after 2 minutes, we'll proceed with the solution. Again, calculate the height of the mountain above sea level if the barometric pressure at the peak is 92,091.28 Pascal, assuming the air density equal to 1.3 kilogram per meter cube. Yep. I'll give you 2 minutes. We have here. Okay, anyone who has an answer? Anyone who can try to answer? Who tried to answer? Hala? Yes, Miguel. Mm-mm. Malapit na, but wrong. Pero malapit na. Other answer, yes. John Vincent Zorilla. Uy,
724.04 meters po.
again, what's your answer?
724.04 meters po.
So the answer is we have answer. We have 724.043 meters. So let's solve now for those who did not get the answer. So in a question like this, we're given of the barometric pressure at the peak, which is 92,091.28 pascals. And we're also given of the density, which is equal to 1.3 kilogram per meter cube. So here in here class, we will use the formula delta P, or change in pressure, is equal to rho g h, where this is the density of the fluid, g is the gravity, and h, this is the delta h. So meaning delta h is h2 minus h1. Since we're in the problem, it is said that we're looking for the height of the mountain from sea level, meaning your h1 is what? Your h1 is 0. And we are looking for h2. So our delta P will be the atmospheric pressure minus the pressure at the peak. So we'll have 101,325. So this, sorry, delta P, ito ay P2 minus P1. So P2 natin is the atmospheric pressure minus, we're given of the barometric pressure, which is 92091.28 pascals. Density is 1.3 kilogram per meter cube, and then gravity, meter per second squared, H2, and then H1 is 0. So 101325 minus 92091.28, what's the answer? Calculator. 101325.
9233.72.
We have 9233.72 pascals. So let's convert to Newton per meter squared, no? For the sake of unit cancellation. So here we have 1 Pascal, 1 Newton per meter squared. 1.3 times 9.81 is 1 point, sorry, 12.75
12.700.
cancel meters na dito, magiging 2. So, kilogram, sorry, wag pala. Baka malito kayo. So, 12 kilogram meter per second squared. Nakikita nyo ba to? Kilogram meter per second squared. What is this equivalent to? 1 kilogram meter per second squared is equivalent to 1 Newton, no? So, we can say that this is 12.753 Newton over meter cube times H2. Okay, so we'll have H2, or the height of the mountain, will be equal to 9233.72 Newton per meter squared, all over 12.753 Newton per meter cube. And what's the answer? H2.
724.042.
Correct. So we'll have 724.043 meters. So this is the height of the mountain. Questions? Okay. So, mag-share lang ako ng additional concept for everyone. Since pupunta tayo ng gauge pressures and manometry, I want everyone to remember these concepts. First, if we are given of a manometer and example, this is our fluid. The pressure here and the pressure here, since we have an equal height, you have here your P1 and you have here your P2. P1 is it equal, greater than, or less than P2 when you have an equal height? Correct. Now, next example, you have here a manometer, and then you have here a different fluid. Let's see. What's the relationship between P1 and P2? Is P1 greater than P2 or P2 is greater than P1 in this case? You have here the height h. So when you see a manometer like this class, solving for P2, example, we're asked to solve P2, no? So P2 will be equivalent to P1 plus rho GH. So example, um this is mercury. So your P2 will be P1, example, you're given 14 kPa plus this is the rho of the fluid here in this region, in this part, plus gravity, and then the height. So in this kind of manometer, when you see this example, you're given two different fluids and there's a height difference, P2 will be greater than P1. Okay? Clear pa? Okay. Next naman, example, you have a tube. Oops. You have a tube. And then it contains different fluid. Example, at the bottom, you have fluid 1. And then at the top, you have fluid 2. So at this point, class, here, like the boundary between the fluid 1 and fluid 2. Example, you have the pressure of the green fluid. The pressure here where the boundary between the two fluids, the pressure between the two fluid is always equal. Remember ha, this is the pressure or the bound in the boundary of the two fluids, meaning you have the same elevation. Next example, we have a manometer, a tube again. And then you have fluid 1 here at the top. And then you have another fluid at the bottom. And then you have here gas. Example, you have here P1. And you have here P2. So in this kind of problem, when you see a manometer containing 3 fluid, including a gas, remember that P2 is equal to, same with this, P1 plus rho GH. However, when we're talking about a gas, remember this class, pag gas yung pinag-uusapan, it is assumed that the pressure difference here or the pressure here is negligible. Clear ba class? Meaning, your pressure 1 is almost equal or equal to pressure 2. Are we clear on this? When we're talking about a gas, remember class, this is gas. It is assumed that the pressure difference between 2 points with a gas in between is almost equal. So your rho GH here at this part is negligible. Okay? Clear doon? Walang question? Naguguluhan? Clear. Okay. So let's proceed to sample problem number 6. So give me 2 minutes lang class. Break muna tayo till 8:12. I'll give you 5 minutes break. Okay, let's proceed to sample problem number 6. Everyone here na? Ah, okay. So can you read the problem, Adham?
Both a gauge and a manometer are attached to a gas tank to measure its pressure. If the reading on the pressure gauge in 80 kilopascal, determine the distance between the two fluids levels of the manometer. If the fluid is A, mercury, rho equal to 13,600 kilogram per meter cube, B, water, rho 1,000 kilogram per meter cube.
Okay. So for this problem, let's first write the given facts or the given data. So we're given of first the pressure P gauge is equal to 80 kilopascals. We have the density of mercury, which is equal to 13,600 kilogram per meter cube, and we're also given of the uh, density of water, which is equal to 1,000 kilogram per meter cube. So for the solution, so first we're asked what will be the distance h. So this distance between the 2 points, if first the fluid used here is mercury. So to solve this problem, first remember class, we're given of a gauge pressure, no? So this is exposed to the atmosphere. So if the other end of the manometer is exposed to atmosphere, what's your pressure here at this point? So let's have this P1. This is P2. What's your P2 gauge pressure, the equivalent gauge pressure if this level or this part of the manometer is exposed to atmosphere? P2 gauge. Anyone? What's the pressure here? This is exposed in the atmosphere. Hello? That's if Yes, that's correct. No, that's correct. 1 atm or the atmospheric pressure is 101.325 kilopascal. But in this problem, we will solve this or everything. We will consider this to be in gauge pressure. So tama, the pressure here in terms of atmosphere. If we're talking about the atmospheric pressure, it's 101.325. However, what's the equivalent gauge pressure at this point? Again, what's our definition of gauge pressure? Gauge pressure is the pressure actually measured using a gauge, and the measurement always neglect the effect of the atmospheric pressure. If you neglect the effect of atmospheric pressure at this point, what will be your P2? What's the gauge pressure at this point? Again, sabi sa definition natin ng gauge pressure, no? Measurements always neglect the effect of the atmospheric pressure. So, what's our P2? Yes, very good. Our P2 here is 0. So, in order to solve for this problem, we'll use again the delta P is equal to rho GH. So, we'll have here the difference between the pressure. So, P1 natin is equivalent to, anong P1 natin? Sige, we're talking about the gas. What will be our P1? Ano yung na-discuss ko a while ago? It is assumed that the rho GH or pressure difference in a storage or in a column or in a manometer containing a gas is negligible. So if you're given here or your reading here is 80 kilopascal, at this point, kahit na meron kang elevation dito, your rho GH here is negligible. So your P1 is equal to, what's the equivalent of your pressure 1? So again, no, we are given here a gauge reading of 80 kilopascals. So meaning class, the pressure inside this tank is 80 kilopascals. I'm asking if what's the pressure at this point? What do you think? Not 0?
po.
Yes, very good. So since this is a gas tank and the pressure difference between any point is negligible, we'll have P1 to be equivalent to the gauge pressure. Okay? So since di ba we have P2, ang P2 natin is equivalent to P1 minus rho GH. So para di malito pala, let's move here P2 minus P1 also rho G. Sorry. Baka lalo malito. Tandaan nyo rin pala class, no? Pag example, at this point, P2, in a manometer, kapag nagkaroon kayo ng differences sa height, as you go down, the pressure increases, no? 'Di ba, halimbawa, meron kang at a sea sa isang dagat. This is another basic concept, no? Example, this is a sea. And you have here atmospheric pressure. So as you go down, the pressure increases. So, ganun din natin siya tinitreat, no? Pag nagkaroon ka ng pressure difference and as you go down, the pressure increases. So, your P1 will be P2 plus rho GH. So, your P1, di ba ito yung P1 nyo? So, P1, lower yung height niya or yung elevation niya or yung height niya. So, your P1 is equal to P2 plus rho GH. Okay? Kaya doon ang galing yung ito. Na-explain ko lang baka malito biglang may sumulpot na gantong formula. So, substituting na the values, what's our P1 again? We have, so P2 natin is 0 na. P1 natin is 80 kilopascal. Oops. 80 kilopascals minus, first is we're asked if the fluid here is mercury, so we'll use the density for mercury, which is 13,600 kilogram per meter cube times 9.81 meter per second squared times, ano yung height natin? Yun yung hinahanap. Okay? Now, para hindi malito, i-convert natin to Pascal, no? 80,000 Pascal. So, 1 Pascal is equivalent to Newton per meter squared. So, we have here Newton per meter squared minus 13,600 times 9.81. So, we have here kilogram per meter squared again. Tandaan nyo guys, no, pag nakita nyo agad to, this is already 1 Newton. So, 13,600 times 9.81. We have 133. What? 133,416 Newton per meter cube times height equals to 0. So, transpose 133,416 Newton per meter cube times height is equal to 80,000 Newton per meter squared. So, height will be 80,000 Newton per meter squared all over cross multiply. Divide both terms or both equations to 133,416. So, cancel natin to. Cancel na to. May matitirang isang M. Our height is, what's your answer, class?
0.0599.
0.0599 dot dot dot. So, rounding to 3 decimal places, we'll have 0.6. No, round up tayo. 0. Sorry. Mali. So, we'll have 0.6 meters. Ito yata is 6 something. So, meaning class, if mercury, yung ginamit dito na fluid, your height difference between 0.1 and 0.2 is 0.6 meters. So, now, question 2. What if naman daw water yung ginamit? So, same solution using water. So, we'll have using water. We'll also have the same formula. Mapapalitan lang yung density. So, we'll have 0. Ito yung P2 times 80,000 Newton per meter squared minus 1,000 na to. Kilogram per meter cube times 9.81. Ito na yung raw GH. Times H. So, we'll have Then 810. So kilogram per meter squared. This is 1 Newton. So 9810 Newton per meter cube. H is equivalent to 80,000 Newton per meter squared. Solving for H, you'll have, what's the answer, class? Correct. 8.155 meters. So, pag ang ginamit pala dito ay water, napakataas nung magiging manometer natin, no? So, the equivalent height is 8.155 meters. So, this is when using mercury, and this is if using water. Okay, any question dito sa problem? Wala naman.
Wala naman po.
Clear naman everything.
Opo.
Opo.
If
Opo.
medyo magulo yung pagtuturo ko, don't interrupt niyo na lang ako, no? Halimbawa, merong masyadong paano naging ganon. Just raise your hand, tapos ulitin ko na lang. Okay? So, later, may sasend na lang ako. So, you'll have one assignment. This will be sample problem number 7. So, i-chat ko na lang sa coordinators, no? Para sabay-sabay yung tatlong sections. Okay? So, yun lang, class. Hope you learned something today. So, next meeting, tayo ay ibang chapter na pala tayo. So, we're done already with the properties of pure substances. Pupunta na tayo on the first law of thermodynamics. Okay? Everything clear? No questions na? Yes, John Vincent.
Ma'am, present po.
Mm.
Hindi lang po agad nakapasok. At gawa po ng update po yung Microsoft ng PC ko.
Okay.
Thank you po.
Lahara, yes.
Present din po, ma'am, ako.
What happened?
Ano po, nagka-internet interruption lang po kanina. Pero nag-chat na agad po ako.
Mr. Ferrer?
Ma'am, ganoon din po ako. Gaya po nung kay Vincent po yung dahilan. Pasensya na po.
Wala ka last meeting, Mr. Ferrer, no?
Opo, ma'am. Absent po ako nun. Pasensya na
Okay.
po.
Catch up na lang ha on the missed lesson. Okay, thank you.
Thank you po.
Yan lang, class. Have a nice day.
Thank you po, ma'am.
Thank you po.
Thank you po.
Thank you.
Thank you po.
Salamat po.
Thank you po.
Good night.